So just as a little background here, when we started looking into economizers and the energy that it would save, clearly economizer cycles are a winner from an energy standpoint. But there was two sort of groups. There was the group that uses economizers that swears there's no problems, and then there's those that don't use economizers that feel that there is problems. And the first problem that industry brought up was the particle, high levels of particulates and humidity. And because there had been early failures in electronics back when boards weren't coated and that sort of thing. So that was where we focused originally, and we pretty much dispelled that particles and humidity don't have any impact on, or don't really aren't a reason to not use an economizer. So people in industry, as Jeff pointed out, now have a new problem for us to deal with, and this is now gaseous contaminants. So in the same way, we felt that instead of doing anecdotal evidence and scare tactics, well, let's try to bring some science to the discussion. And Henry Cole's from Lawrence Berkeley Lab will talk about our ongoing effort to evaluate gaseous contaminants in data centers.
As evidenced by Armand's talk and Dale's introduction, LBL has continuing interest in encouraging data center operators to use outside air for cooling purposes. As mentioned, many in the industry are reluctant to use outside air for cooling. And also, as Jeff mentioned, there was an ASHRAE white paper that came out last year, and it created additional concern. One thing we did hear about is a federal agency rejected the option of using outside air cooling after they had read this white paper, and this sort of piqued our interest, and we got some funding to look into the situation a little bit more. The activities that we're taking place now up at LBL, we formed an industry advisor group consisting of IBM, HP, Intel, Dell, Seagate, Micron, and Purafil. We wanted to work with these people, these companies, to try and get the best and most current information available on the issue, and to find out what each company is doing to investigate the issue and so forth. Also, I think Jeff mentioned we did a literature review of the ASHRAE white paper, and you can get that on our website. There are a number of other groups working on this problem, and they're actually making pretty good progress. For example, ASHRAE is got a project underway. The 311G committee, headed by Helen Holder at HP, is coming up with a mixed flowing gas test that they hope that can be used to determine the survivability of various kinds of electronic equipment. INEMI also has a project underway. There's no perfect way to measure the corrosivity of gaseous contamination, but the most common method used right now is to use these copper and silver test coupons. We started a project, and we're deploying these copper and silver test coupons in about 18 different locations across the United States to get a preliminary idea of what the corrosion levels are with the currently measured method. The questions to be answered are the corrosion readings using coupons, are they consistent? Also, is there a correlation between silver and copper coupon corrosion rates? Certain conditions, for example, high humidity conditions and low humidity conditions, affect the copper and the silver rate. And we found that the ISA committee, the G1 level, only refers to copper. So if somebody says, well, my silver coupon rate is 300, well, there's no official number for that. So they're working on it, but there's still no official level for silver. We found that from other coupon information that we've gathered from companies that have used these coupons, that the silver coupon corrosion rate looks like it is more indicative of electronic failures, not necessarily copper. So it could be that people are looking at the wrong number. So anyhow, we want to find out what the correlation is between the two. We also are concerned that areas that are highly concentrated with data centers, for example, Santa Clara area, there's a lot of companies here that have data centers. In New Jersey area and Research Triangle Park, we want to try and cover those, see if there's some particular danger there. Also, we want to determine in a given location if we have a data center that's closed, how does it relate to a data center that's open that's using outside air economizing? So if we can find a location with two data centers, maybe they're a mile apart, we can put measurement coupons in both places and get an idea if there's a difference. The other thing we want to determine is when the air comes from the outside, it can easily be filtered, as Armand explained. So that part of the problem is now pretty much removed. We want to determine now that air that comes in, is that any different than the air that ends up being circulated in the data center? There's some chemical reactions that can take place that can reduce the severity of the corrosion inside the data center, so we want to test for that. Last but not least, is there a correlation between coupon corrosion rates and equipment failures? Well, Bill Schutte, who's in the audience here, and some others we've posted on forums, data center forums in the United States, and I guess it would go out around the world, asking, does anybody have, a case where they had a failure, they know it was from corrosion, and let us know about it. So we did not get any responses. We have one anecdotal experience. I was here in Silicon Valley where some data center equipment had some problem, and it turned out to be a sewer P-trap had run dry, and there was sewer gas coming up in one particular part in the data center, which is a little bit embarrassing, but it caused a problem there, but we still was not able to investigate exactly, okay, this resistor corroded and so forth, so we're still counting that as anecdotal evidence. But in any case, it wasn't caused by outside air. For those of you not familiar with what these corrosion coupons look like, there's a couple companies that make exactly this. There's a copper strip attached to a small plastic board that's about 3 inches by 4 inches, and a silver strip. And you place these in your data center in a number of different locations, and you send them in to be read, and they'll send you back the results. The criteria for selecting the sites are as follows. We wanted to look for sites that have high EPA readings in sulfur dioxide. That's one of the things that the EPA looks at. Turns out that the air quality in the United States over the last 15 or 20 years has really gotten very good. So it's not easy to find a city that has high levels. We found a few, and we have coupons placed there. The other is areas with outside air cooling and inside and a closed data center in close proximity, as I mentioned before, areas in high data center location. And so we focus mainly on the US, and we have 2 sites also in Bangalore, India, to just see if there's any high levels or high readings that can be obtained there. The coupons are placed in the data center just past the filters. Owing to Armand's research, the filtering can easily be done, so we don't want to burden the experiment with dust getting on the coupons. So we place 2 coupons in each data center just after the filters. And also inside the data center near where the servers are or at the return duct. Here are the locations of the coupons we placed around the United States, mostly concentrated on the east and west coast, some along the lower part of the United States. I think there's probably not too many data centers of concern in Montana, but so we didn't place anything there. And then the 2 places in India are indicated there in the same city. Current status, we have 99 coupons have been sent out. 58 coupons are actually now, about 90 coupons have been placed, so we almost all have them placed. The target measurements are to be returned by November, end of November. We estimate the report to come out early next year. We're going to continue monitoring the industry progress and evaluate the results of the coupon survey and then determine what our next steps are. Thank you.